All right, I thought I had done this, but whatever. Technical difficulties, such as life. This means I've just had practice. So let's take a look at the chapter 15 stuff, and to make that work, let me really quickly switch classes so we can see the graph in the textbook. And I'm also going to use a spreadsheet to draw out this story because it lets me have the computer do the hard work of actually calculating stuff. And then I might also have to use my whiteboard because MindTap is less than fully cooperative. So let's see, Graph Builder. This should be what we're looking for. So the difference between monopoly and perfectly competitive markets, the logic is very, very similar. The big difference boils down to the demand curve that either one is facing. So for a monopolist, if we think about, let me make a point here. If we think about something like Apple, does Apple have a monopoly? Well, yes and no, right? It depends on how you look at it. They certainly have a monopoly on iOS smartphones. They have a monopoly on the iPhone. But there is the Samsung, and there is, cheapo Motorola smartphones. There are alternatives. So if we define the market as cell phones, or if we define the market as computational devices, then no way. But if we define the market narrowly, then yeah, they do have a monopoly, right? If we think about, say, premium devices that work nicely and aren't owned by Google, okay, then maybe they have a monopoly. That said, we're just going to push that issue to the side. When we are thinking about monopolies in real life, defining what market we're looking at is an important question to ask. But for here, we're just saying we've got some market. Now, here, we've got the graph. So the difference between a monopoly and a perfectly competitive demand curve. From the perspective of the seller, their decision is, what do we do in terms of, well, let me rephrase this. Actually, let me just start from scratch. I'm going to stop the stream. I'm going to go delete the video. Let's talk about monopoly. The difference between monopoly and perfectly competitive firms boils down to the demand curve. Right? The logic is going to look very, very similar in a lot of ways. They're both trying to maximize profit, and they both have some choice about how much to sell. Right? So we're holding a lot of things constant here. We're saying, all else equal, we're defining the market as whatever the market is, whatever quality of good, whatever terms and conditions. All we're changing is price and quantity on this graph. In the case of a perfectly competitive firm, they don't get a say about the price. So if we think about someone pulling oil out of the ground, they sell at whatever the market price is, and that's determined by the aggregate outcome of all the buyers and sellers. But if we think of a very large firm, their decision to sell more could result in a lower price, right? If they put more out on the market, in order to be able to do that, in order to get people to actually buy the stuff, they're going to have to lower the price. Now, we're also assuming one price. So not all monopolies work this way. And there are a lot of clever ways that firms and industries will find ways to charge different prices to different consumers. So even something like TVs. TVs are a very competitive industry, but if you look at Best Buy or PC Richards or wherever, sometimes they put stuff on sale. And really what a sale is a way to charge a higher price to impatient people who aren't ready to wait for the sale, and then charge a lower price to cheap people. And that means that they can get the benefits of a high price, and they can also get the benefits of an increased size of their market. Student discounts at movie theaters are very similar, right? Movie theaters are even easier because in that case, I can't just go out and buy a bunch of tickets when they're on sale and then sell them on eBay. You don't see old people standing in front of theaters trying to scalp tickets using their senior discount in order to sell to people like me who don't get that senior discount. So we're assuming one price, and that makes a lot of sense if we think about, say, if Apple sold you an iPhone for $800 on a student discount, and they were going to sell it to me for $1,200, I would just go to you and say, give me your phone, I'll give you $1,000. Right? In that case, they don't get the $1,200 from me. They sell you 2 phones at $800, and then you get a couple $100 in your pocket. So when we have a market like that, when it's easy for us to move the good from one person to another, it's really hard to charge more than one price. They still try, right? Somewhere around here, I'm not going to actually show the evidence, but if you look for textbooks, very often you'll find the international edition is a lot cheaper. And that's kind of the same thing, except with eBay, it's a lot harder to do that. And that's part of the reason that Cengage has worked so hard to create MindTap. That's something that makes it so they could just charge a different price for MindTap in India compared to what they charge here. Because you guys are rich American students who can find more money. You're not in a developing country where it's harder to find that money, and therefore they just need to charge a lower price to maximize their profits there. If you're interested in sort of the specifics of things like that, send me an email or take Eco 250 with me. We'll delve more into the mathematics of this stuff in the fall. But let's get into it. So actually, let me start with the spreadsheet. So this is my 101 demand curve. And what's going on here is at a price of 101, we sell 0 units, and we lower the price by 1 and increase quantity by 1. We have a -1 demand curve, -1 slope on our demand curve. So the top end hits the price axis at 101. At the bottom end, we hit the quantity axis at 101. That's why I call it the 101 demand curve. And it's really nice. We didn't cover chapter 5, but it's really nice for thinking about elasticity because it's easy to put this in percentage terms. So when we go from selling 1 unit to selling 2 units, we've got 100% more sales, but we've lowered our price by 1%, right? 100% increase in quantity, that's more than enough to offset a 1% loss on the price end of things. And we can see that our total revenue goes from 100 to 198. Now, here is where things really start to diverge between monopoly and perfect competition. In perfect competition, if I sell 1 more barrel of oil, I get another $50. I sell another 100, I get another $50 for each one. But if I'm a monopolist, if I sell 1 more, I have to lower my price. And since it's 1 price, I'm giving up the chance to charge $100 to someone, so I lose $1 that I could have had. But in this case, I pick up $99. $99 minus $1 gives us $98 marginal revenue. Our marginal revenue curve ends up being below our demand curve. That's what this red line is telling us, right? As we sell more, we don't get this price. Now, we get that price on average, right? We're charging this price for every unit that we sell, but going from a little bit less to Qmax to actually at Qmax, we're lowering our price, and so we're missing out on a slightly higher price for a bunch of customers in order to pick up a bunch of extra money from 1 extra customer. So let's go ahead and try and draw the graph. You know what? I'm going to do it on the whiteboard because that's just going to make my life easier. So we've got our demand curve. And all I'm describing here, this marginal revenue logic, let's see if I can reduce the glare a little bit. Is that better? I'm going to move to the part of the whiteboard with a little less glare. Quantity, price, demand, and that's pretty faint. There we go. So if I charge a high price, I get all that revenue, right? So I sell, say, 10 units at, let me look at my spreadsheet. If I'm selling 10 units, I'm getting a price of $91, which means I'm getting $910 of total revenue. If I lower my price by 1, now I'm getting $90. I'm missing out on $1 times 10 units. So I'm losing $10 by lowering my price, but I'm bringing in an extra $90. So this rectangle is worth $90, and it's hitting our price axis, or it's hitting, the demand curve at that price of $90, and that tells us price equals $90 equals our average revenue. But to ask the marginal revenue question, I have to take away this rectangle. So I take that rectangle. This is a rectangle of 1 times 10. So I'm taking away $10 out of this $90 rectangle. Something like this. And now I've got my marginal revenue for that 11th unit is down here. Right? I know it's hard to see. So this point here, it's below the demand curve. Right? So we get a marginal revenue curve that looks like this. And it goes down to a negative level because at some point, right, if we're at this point, we sell one more unit, we bring in some extra money, but we're losing an even larger amount of money that we could have been making if we sold one less unit and just charged a higher price. That's the logic underlying the marginal revenue curve for the monopolist. Right? Because they're so big, in order to sell more, they have to lower their price. Compared to perfectly competitive, they sell more, they have no impact on the price. Price is equal to average revenue and marginal revenue. Here we have this disconnect. Now the marginal revenue is less. And the problem with that, in terms of efficiency, is the marginal revenue is the benefit to the monopolist, but the demand curve is telling us the marginal benefit to the consumer. We want to see the most benefit to people, period, net of the marginal cost. We haven't thrown that up here. We'll do that in just a second. I have done a simplified version of this in class where we just said, let's assume a constant marginal cost. I'm 80% sure I've done that. I'm going to do that on this messy graph, and then I'm going to draw it slightly differently. So given this marginal cost, right, we're assuming away fixed costs. We're just saying it costs us, say, an extra $10 for every unit we sell. In that situation, we go to where marginal revenue equals marginal cost. Sorry, I thought I heard something in the background. We go to that quantity, and then we charge. I don't know what that sound is. I might just be having a stroke. We charge whatever price the market will bear. All right, so we get this amount of revenue. I'm going to make this just double down on messiness. We get all that revenue, this big red rectangle, and then we subtract out these costs, and we've got this profit here. What we can tell from the marginal revenue and the marginal cost is if we go further, we're going to be adding more to our costs than we are to our revenue, which means our profit is going to be lower. If we cut back, we're going to charge a higher price, which means more revenue on average, but across fewer units, which means we're missing out on the chance to bring in, let's say, an extra $12 of revenue at $10 of cost, which means we're turning down $2. We don't expect firms seeking profits to turn away $2 they could have had. So we expect the monopolist to go to this point. Now, let me draw the slightly more complicated version. The marginal cost curve that's more in line with what you saw in chapter 14 and what we kind of glossed over in chapter 13. We still have our demand curve, but now our marginal cost curve looks like this. Law of diminishing marginal returns. If we sell more, we're going to face higher costs, at least past some point. So let's think about a specific example. You guys might not know this, but I have the monopoly on tourist trips to the dark side of the moon. If you want to go to the dark side of the moon on vacation, get in a spaceship and go there, you come to me. Now, I happen to know, based on my market research, that the most anyone's willing to pay for that is $1 million. Right? It's a little bit more than $1 million, but I'm going to round. The trouble is, the average cost for that is pretty high. It's higher than the marginal benefit that we get from the demand curve, which means I can't profitably run this business. Right? So I have a monopoly, but it's at the shutdown point. I can't cover costs, so we just don't send anyone to the moon at all. But let's imagine that maybe through technological innovation, we're able to drive those costs down. We're able to find a cheaper way to do it. In a case like that, we bring our average costs here. We still have to tell our marginal revenue story. That looks about right. Our profit maximizing point is where marginal revenue hits marginal cost. Let me tidy this average cost up a little bit. The average cost always hits its minimum right when it's crossing the marginal cost. So this should be a little less flat. Let's put it like that. And let's go ahead and use blue just to distinguish. So here's our quantity. That's going to maximize profits. At that quantity, we charge whatever the market will bear. We charge the highest price we can get away with to sell that quantity, which puts us up here. Price equals average revenue. And again, we're charging just one price. Now, really, if you're talking about tourist trips to the moon, there are ways to charge different prices for different people. You have first class tickets, you have sales, you charge a lower price for people who plan ahead, and you charge a higher price for people who choose to go at the last minute. Those are ways to get different prices for different groups of consumers, but let's just simplify and say we've only got one price, so we've got this average revenue here, and then we take our average cost. So our revenue is this whole rectangle. We take away the cost, and what we're left with is our profits up here. It's our average revenue minus our average cost times the number of units that we're selling, the number of tickets in this case. So that's how we find profit on a monopoly. But like I said, if the average cost is too high, then the monopoly doesn't even matter because it doesn't operate at all. Cool, let's stop there. I think that's the graph. Well, actually, one last thing we should talk about is the dead weight loss. Now, it gets a little bit tricky when we start to think about average costs here, but we still have this point where these buyers get a marginal benefit that's greater than the marginal cost of actually sending them. So if we could find a way to charge this price and then find these buyers and give them a discount, right? Maybe charge them this price. If we could get to that point, we would still get this profit from these customers, but then from these customers, actually it would be a little bit different because our average cost would be a little bit different. The math gets tricky, but we are, as an economy, missing out on some dead weight loss here, right? So as economists, we would like to see this monopolist sell more in order to get all of the mutually beneficial exchanges. But what's probably most important is just recognizing we maximize profit where marginal cost hits the marginal revenue line, because going any further means we're adding less to our revenue than we're adding to our cost. We don't want to cut back because that means turning away the opportunity to make money that costs us very little to bring in. This is where we maximize the profit, we charge the price that we can get away with, and we're left with this area as profit, which is just the price minus the average cost to get to that level. All right, let's stop there.